Okay, this is going to be a video to help explain how to make phase diagrams in MENG 3320 thermodynamics, and we will be starting with some data that is SI units of water, creating a saturation curve for a TV plot. We'll create a isobar to go with it, and we'll try and put a unique point on there as well with some callout information on the diagram. So let's get started. First, we need to go to WT class and download the individual PDF of the data. So I'm going here to WT class homework, and at least for right now, it's under the property diagram. I'm going to download these SI tables, and I'm going to save them somewhere on my computer. It's not going to work that way. Let's see. Oh, I can open it here. Okay, now I can save it, and this is in Chrome. The reason I want to save it is the data grabs much better directly out of the PDF in a copy-paste mode if you actually open it in a true PDF viewer or reader. So I'm going to save it on the desktop for now. Get saved. I'm going to open it. Okay, I'm not going to open it that way. Go to the desktop and let's see, where did it go? Okay, let's try it again. Save as desktop. Okay. Acrobat. All right. Okay, now it's open in Adobe Acrobat. And to make the saturation curve, I'm going to need to go to the saturation table, which is, if you look here, table A4 and A5. And I want to make a TV plot, so using the temperature data makes more sense to do that naturally. So I think I can grab all of this. Let's try it. I mean to not grab the title. Copy, bring it into a new Excel document, paste data. Okay, so it looks very jumbled. So I grab the entire column, click on data and text columns, and the data is delimited by spaces. It's separated by spaces. That's how we can view this. So click next and choose. It has tabs on delimiters, but it's not showing any separation here in the preview because there are no tabs. So if you click space, you can see that it starts to make sense. The numbers are breaking out now. You can really skip all this stuff. You don't have to worry about these and just click finish. So it's fairly well broken down, and I actually have my columns preserved, also my column names. You want to verify that these units are correct, because I think some of them got shifted, looks like. And it looks like some of the columns probably did too. So let's see here. For what we're doing, we don't need anything other than the temperature and pressure and volume. So I'm going to get rid of these other columns for now. So first one is temperature. This one should be pressure. Okay, then the next one is VS. I'm going to move that over. Then VG. And you can go ahead and move the rest of them to see if they line up. And they do. So I guess I'll just keep these here for now so you can see how it would work in a broader sense. I'll get rid of all this extra stuff here. Okay, I like to shift everything to align better. Alright, so here's what it is, and then here's the unit. If you go back to your PDF, you can see temperature in degrees C, kilopascals, meters cubed per kilogram, energies are kilojoules per kilogram, and entropy is kilojoules per kilogram K. So I'll just type those in. Insert symbol, degree, C, kilopascals, I like to go and put the subscripts on these. Control, or actually, yeah, you have to go to Format. Let's see, where is that at? Number, nope. Format. There we go. Format cells. And I can put my subscript there. I'll just use a shortcut for the rest of these. Okay, that's probably good enough for now. You get the idea. It's kilopascals, these are all meters cubed per kilogram, kilojoules per kilogram. Just copy these over. And then entropy, kilojoules per kilogram K. Okay, so now I have all the columns here. You can check them to see if the numbers are right. Go and divide them up there. And so you've got everything from 0.01. So go ahead and put a good label here. This is a saturation table, property table, data set, SI units, water. We go to the bottom, it stops at 200, and if we look here at the table, it goes on to a second page. So I'm going to go ahead and grab the second page. That'll give me everything I need. Paste it down below. It already figured out how I wanted to break the data apart by spaces. So I know these columns all align, so I'm going to go ahead and just delete all this stuff that I don't need and connect the data directly here. Okay, so now I've got from 0.01 degrees to 373.95, which is the critical temperature. So just if you want to mark it, remind yourself of that. Critical temperature. And the reason we know that is because this, well, you can go ahead and freeze the top column. Might be useful for you to do that. Grab that row and click View, Freeze Panes. Okay, that's not exactly what I want to do it this way. And freeze here, okay. Freeze panes. Okay, now this is all preserved, so you can see your stuff. But if you look here, UFG is 0, HFG is 0, and SFG is 0. That only happens at the critical points, and that's what this is. This is the critical point here. It's always the last one in these tables. Okay, so now we have all that data. We're also going to need, so this is our original data. We're going to need an information for an isobar. So we're going to get a superheated property table. Property data SI, also units of water. And I'm just going to pick one. You can pick any of them. They all work the same. If you need to do multiple isobars, just grab more tables. So go to this section here, the superheated water table, A6. And we'll do this 0.4 megapascals. So I'll grab all of this here, paste it. It's already separated it here, and I only need the ones for 0.4, so that should be the last 4 columns, starting with 0.46242. Let's see. Okay, that's a match there. So I'm going to get rid of all these other ones here. And cut these and move them. This saturation will be the saturation temperature, which I can see right here, 143.61. And I can grab a lot of the same columns here. I think, yeah. Except this isn't going to be P set, this is actually the volume. So it's volume, internal energy, enthalpy, and entropy. So volume, internal energy, enthalpy, and entropy. But the units will be the same. Joule per gram, okay. And this pressure is just P, and it's the constant pressure. It's a constant pressure of 0.4 megapascals or 400 kilopascals. Okay. And then the last thing is, let's say I want to pick a point that's a mixed quality that I'm going to put on there. So you're going to calculate one in yours, but I'll just put one here. Point of liquid vapor saturated mixture, water. So I'll grab one that's on this isobar, I think. Let's see here. Or one that's at least near it. The closest point, oh, I know, I need to actually go grab from the 400 table. So I've got this isobar here. If I go to the 400, the pressure-based table, here's my 400, here's my saturation conditions. So I'm going to grab these numbers here. Okay, so this one is temperature, that's the saturation temperature, sat. This is pressure, kilopascals. And those first two columns here are, of course, VF and VG. And just for demonstration, I'm just going to pick a quality of 65.65. So this is the data here. This is the calculation for point. So the pressure is still going to be the same, 400. Temperature is going to be the same. One, 3.61. And then the quality I just put in as a formula here for the specific volume. So, let's see, the volume would be quality times the difference between these two, which is like a VFG plus the VF. So that's in the middle, about 65% of the way between the VF and the VG. V meters cubed per kilogram. So if we survey what we have now, we should have all the data we need to build a plot. This first one here will be used for the saturation table, the hump, and then we'll use this superheated table here to build our isobar in the superheated region, and then this data here was used to find the quality of 0.65 and the specific volume associated with that, so we can make an individual point. So I like to organize the original data and then the plot data. So here's the saturation curve. Now all these are made up of just temperatures versus volume. So we'll put in volume here and temperature. Okay, and then as I showed in class, you need to put phase here because it helps with sorting on the saturation curve. So we'll start with saturated liquid. We'll put all our volumes and temperatures. So here's our original temperatures. So we'll put all those in, and then we need to grab only the saturated liquid volumes to go with it, which is just the VFs. Alright, so then saturated liquid, and just copy that down to mark where it is. Now below that we put our saturated vapor data. It's going to be the same temperatures again, because it's just the temperatures that correspond to those saturation states. And then you just make sure to grab the VG data instead of the VF data. Here's saturated vapor. Copy it down. And now to make it come out right, I could show you what the bum curve is going to look like, but you just need to sort it so that the lines and points will connect properly. So grab everything, including the column titles. You can start here, do Control Shift right, and then keep holding it and press down. That selects everything. Then go to Data and Sort. Sort on two levels, so add a level. Sort first on phase, then sort next on volume. Phase you'll want to do alphabetical so that saturated liquid comes up before saturated vapor, because L before V. And then you want to sort on volume because you want the volume to be always increasing. So we hit sort, and you can see it didn't change anything on saturated liquid really, but now the saturated vapor volumes are always increasing, and you can see here's the critical point, and here's where they line up. The two curves touch right here. So this is really, if you want to mark this is the critical point. So really you only need one of these. There's really only one, but we'll just keep two for now. The points will just overlay each other. Probably won't hurt anything. So that will be your saturation curve. Now let's set up the data for the isobar. Isobar P equals 400 kilopascals. So for that one, you need to have the same columns. We need a point on the far left, that's the saturated liquid. We need a point on the far right of the saturation curve, saturated vapor. And then everything else is superheated for as much data as you have. So the saturated liquid at 400. Go to 400 here. 400 over here. Here's our saturation. So we have 143.61 is our temperature, and here's our two volumes, VF and VG. So VF, VG, you can just move them over here. VF and VG. And that saturated temperature is here, 143.61. Here and here. And then everything else after this is going to be from the superheated data, which is everything you got here. So we go from 143.61, 143.61. We don't need this data here. We only need 150 and higher. So here's temperature. And then here's volume. Okay, superheated. Okay, now we've got, here's your isobar, your saturation curve, and now you need the individual point that you're going to put on that. Individual point for display, which you can put as many as you want. If you want to put the same columns, you can, but you don't have to. So phase is going to be mixed liquid vape. And then we've already got the saturation temperature. We've got the points here. I'll just paste them here. This one, smaller one, is the volume. Here's the temperature. And you can see each one of these is X and Y and X and Y. You can put them in quotes if you're trying to remember that. Just helps you just learn how the plotting is going to go. XY, XY, XY. And now they should plot fairly easily now that you've got all this in here. The last thing to consider is you're going to want to put, you may want to put some extra data in here later for H and S. If you wanted to calculate these, for example, you could put them in an annotation. We might do that on another lab. If you calculate those, you could put them here and then use them in this point here. But we'll just use what we have. So Y versus X, T versus V. If you grab everything, including the column titles, hold down Control Shift right, Control Shift down, scroll back to the top, put in your insert scatter, and you want to use this smoothing kind of scatter. So it looks really funky. So we have to change this axis a lot so that we can see the actual size of that envelope there. So I'm going to right click, say Format Axis, and limit the axis on the volume to, so if we look here, the volume starts to get really big, so probably something around 1 or 2 is probably all we have to show most of the data. There's just a couple points that are out here in these really big volumes. So we'll just take it out to 2. Okay, still I can't see very much of the apex, so let's just take it out to 1 and see what that does. Doesn't look so bad. Let's take it down to 0.2. And now you can see some of the curves, so we'll leave it there for now. I like to erase these lines. I click on them, press delete. I'm going to delete the title. I don't like to use titles and the figures very much. Make it a little bigger. Change all the text to be, I like to say, make the text as big as you can have it be without overwhelming somebody. I like to change this so I can see the border separately and then get rid of the outside border. It's just my preference. Okay, and then you have to put labels for all axes, so go to Layout, Axis Titles, Primary Horizontal Axis. Of course, this is our specific volume, meters cubed per kilogram. And on the Y, you have temperature. I think this will work. You can still put in degrees C. And that corresponds to what we think, 0 to 350, and then small volumes. So there's your saturation curve. Now we need to do an add series. So right-click on it, do select data, and you can say add a new series. And this one is going to be called this isobar. So just click there in your title. X values are all these ones here. I'm going to just do Control-Shift down, make sure I got everything. And then on the Y, make sure you go to your temperatures. Do it the same way, Control-Shift down. Click OK. So we've got some big values out here. So if we go back and look at the full range, it's changing that axis because have some very high temperatures here. We don't really need to see all that though. So I'm going to limit the temperatures to the highest critical temperature we'll see was about 373. So we'll just make it 400 to cover everything, I think. Okay, and then change this back to 0.2. Okay, but we can't see the whole range of the bubble there, so we need to make that a little bigger so we can see all sides of it there. So let's make it 0.5. Okay, now we can start to see it. Go ahead and make it 1. Okay, now you can see a little more. And at least that's reasonable. You get the whole saturation curve and a good amount of the isobar. And there's this little blip here because the way it's connected. If you change this to be, click on just the red one, right-click and say change series chart type. If you make this one a rigid connect instead of a smooth connect, it'll get rid of that extra little blip in there. So now we need to put in our single point. So our single point is here. So do again, click on it, select data, add a single point, and just call this point of interest, something like that. Your X is the volume, single point, and the temperature that goes with it. And you won't be able to see it because it's looking for a line to draw, and it can't draw a line because there's a single point. So what you have to do is go to Format and find everything in the list here. You can click on individual series, click on the point of interest, say Format Selection, and change the marker to have the built-in marker, have no line, and now you can see the dot there. I'm going to make the dot a little bigger. And it should be about 65% of the way through the line, and it looks like that's about where it is, because that was what we calculated. So if you want to now add an annotation to show this, let's go ahead and put a legend in here. The legend. Okay. So let's change. This T should really be called something like saturation curve. That makes more sense. Okay, so I got these. I'll make it a little bit smaller so it doesn't overwhelm everything. Alright. Okay, and now we can click on it, say insert, put in a text box, draw it in here, say quality of 0.665, put the pressure isobar 400 kilopascals, temperature equals 143.61 degrees C. And then put the volume that we got there, 0.300952 meters cubed per kilogram. And just go ahead and put there to highlight what it is. get a little bigger. Okay. Make it a box under here. Simple box with border. Oop. Format box with border. There you go. Okay. And you can do insert shapes arrow and just connect the arrow there to point exactly to what we're talking about. And that's mostly what you have to do for this. There might be a few other random things. So then you can grab this, copy it, open Word, do paste picture. It makes it look a lot better that way usually. Then you can right click here and say insert caption, figure 1. You can say TV property diagram with isobar and point of interest at quality of 0.665. And now you've got a label that goes with it. If I make it a little bigger, change it to black. And this is generally how I want you to present all figures in this class, and really anything you do for me. It looks clean, the axes make sense, the units are labeled, all the series are clearly labeled, you've got useful annotations, and you've got a good caption. And that pretty much covers what you have to do for a lot of different phase diagrams in this class and a lot of other kinds as well. So I hope this was helpful for you all. Please give me feedback if you got it.